Good evening. Today is the very last day of Golden Week, which is holiday season in May in Japan. Tomorrow I have to get up at regular time and go to my office. I'm really looking forward to meeting my colleagues again. Anyway, let's dive into today's topic. Tomorrow I will have the meeting with internship student. So this is the last practice of the presentation. I will guide him to our department and thesis. Okay, let's try that. Okay, now I will talk about the thesis of your internship. Today, I will cover with four main topics: our products, the software you will working on, and your challenge, pre-study. And we have several categories of our products. And in our department, specifically, developing the board testing equipment, we call it ATE, which stands for all testing equipment. Okay, our product looks like kind this. There are four independent robot arm with probes, and now this is the inside of our machine. Probes hit the part on the circuit board to inspect patterns created as correctly as designed. And I've already read your resume and you have experience designing and creating PCBs, so you've already known about it. The board, what I said, is like this. And now, in this right side picture, says that probes are hitting this board to inspect. Okay? And from now on, I'd like to walk you through our main major inspection. At first, continuity test. Here is the picture of the board, and now probes are hitting the patterns as far from each other. And then we now apply the voltage and current and measure the resistance. Then if the resistance is quite higher than reference value, then these patterns has defective point like this open pattern. On the other hand, resistance is lower than reference value, then this is good pattern, not defective. Controversially, we have isolation insulation test. Now we our probes hitting to the each patterns, and if we apply the high voltage, then if our product detect that current flows, then we can decide and judge these patterns are short. Accidentally or intentionally, patterns are connected somehow. But if the resistance was quite high, then these patterns considered as separated, so it's a good pattern. Okay, so now we have some problem. We have question: how do we find these testing points? When it comes to finding the correct testing patterns, we have the software deal with this problem. UA 1781 This is a software that allow you to generate testing point using Gerber data. Probably you've already well known in Gerber data, but just in case I will walk you through briefly. Gerber data is a set of vectors, consists of apertures, lines, arcs, and polygons. Aperture is the shape and size of the tool, like tip of pen. And if we flash the aperture at the specific point, then the part is created. Can you see this circle? This is probably given by aperture's flashing. Then part has been created. And lines are defined by moving the aperture from point A to point B, like this. And arcs are created by the uh, same the way of seeing. Furthermore, polygons has a common rule is passed around counterclockwise was defined a field data. So these things using these concepts of Gerber data, as you can see, this layout design of the board has been shown. And then, using Gerber data, how do you identify the endpoint of the patterns, probing point? This is our main concern. For example, now, can you see this magenta pattern? This is connected electronically. And at a first glance, you can't see this pattern and this pattern as not connected. But actually, these are connected because this board is a multi-layer board. So throughout the other layers and vias, these patterns are connected. And the probing points should be placed as far apart from each other as possible. So probing point should be placed here and here to inspect and run continuity test. And then our goal is generate a probing point for inspection. And in order to realize that, calculate the connection data. And to be honest, these functions are already developed. However, we have current challenges. Let me describe it. PCBs are becoming denser and more fine-pitched by year by year, and existing algorithms can't handle the level of complexity. Then, I'd like you to develop a new algorithm built for high-density PCB data. This is your thesis or internship. Got it? So let me wrap it up. The objective is using raw text-based data, Gerber data, calculate where the testing pattern should be more quickly and precisely. This involves two major technical hurdles: identifying endpoint and distinguishing connections. And then your challenge is develop a new function that overcome those hurdles. Okay? Let's move on to the next topic. So this is a pre-study. Probably you already well versed in Visual Studio. This is a coding environment we will use in internship. So, and also I want you to study Gerber data and PCB structure briefly. You don't have to dig deeper in these topics. Okay, so as for Visual Studio, Visual Studio community is available for free, so install and try to use this software and try to write a code in C++. And also briefly study the global data format. It's enough to understand what kind of data it is, what this data looks like. This is enough. Okay, that's it. Thank you for listening.